Hey Algebra 2, here are the notes for Lesson 5.3, Solving Quadratic Equations by Factoring. There's been quite a few issues with my last couple videos, and I think it's been because of the pace that I've been going and how I have to pause the video every so often. So in order to avoid that, at a few points in the video, I'm just going to slow down and pause just to make sure that I haven't overwhelmed my camera. So if there's a random pause, just know I'm just trying to recalibrate everything. Alright, if we know that a times b is 0, what has to be true about a or b? Well, if a times b is 0, one or the other has to be 0. That's the only way where their product can be 0. This concept is known as the zero product property. So, two things multiplied to 0, one of them's got to be 0. So when we want to start solving equations by factoring, our first step is obviously to factor them. So this one we're going to factor into z equals -3, z equals -9. And based on zero property, I know that either z minus 3 has to be 0 or z minus 9 has to be 0. Based on this, I can solve these two pieces and give my solutions of z equal to 3 or z equal to 9. These are not only the solutions, but they're also the roots and where my parabola is going to cross my x-axis. So if you remember from our solving by graphing, before we were graphing and trying to find where it crossed the x-axis, now we don't have to go through all that hard work of graphing. We can just, excuse me, we can just solve it this way. So another one here, it's not in a zero product form that I like, so I'm going to set it equal to 0. This way I can now factor it and set it equal to 0. If it's not there, I can't do anything. I have to then solve it this way. This is a negative, that's positive. I'm not going to go through how I'm factoring all of these. That's something that we need to be good at after having done the homework and practiced. Technically, factoring is Algebra 1 concept as well, so I'm just not going to go in depth. If you want to know more on how to factor these or you're really struggling, there's plenty of videos out there, or you can come and ask questions. But either way, I'm going to set those two things equal to 0 just as I did in the last one. Again, the thing that allows me to do this is my zero product property. And my final two answers are s equals -2/3 and 5. Notice here I didn't solve this one, I just moved it down and set equal there. Alright, this one, not equal to 0. Don't really like working with a negative out front, so I'm going to move this to the other side and that to the other side, because what that allows me to have is everything positive. I then know the only thing that multiplies 20 to 2 is that. When I solve both of these, I'm going to get c equals -1. Because they're the same factor, there's really no need to repeat it, so I don't have to write it twice. Alright, going over here, if I'm setting equal to 0, I move the 49 to the left side. I notice this is in a difference of squares form, so I can immediately say what's the unsquared version of the first term, what's the unsquared version of the second term, set equal to 0. Some of you would want to divide this by 16 and then take the square root. You can do that as well, it's just not going to look quite as nice when you factor it. When I solve these, the only difference is one is going to be +7/4 and one is going to be -7/4. So what I'm going to do is just write x equals plus or minus 7/4, save myself some time. Alright, jumping down here, I have to put it in that form that I'm used to. However, when I do this, this isn't in any of the forms I'm familiar with, so what I'm going to start by doing is factoring out that GCF. Doing this allows me to then factor this piece into a difference of squares, which is m minus 6, m plus 6. Bring the m down. And notice, zero product property doesn't just have to work with 2 factors like it did up here. It can also work with 3. So any 3 of these factors could be 0. So I have to say m could equal 0, m minus 6 could equal 0, or m plus 6 could equal 0. All of those are options, and I have to solve them all to see what my options are. So 0 is an option, and plus or minus 6 is an option. So the only thing we've really added from today to yesterday is just this ability to go from the specific factors down to the solutions or the roots. Alright, when we flip this over, sorry about that, hopefully we're still filming here. Alright, so the intercept form of a quadratic equation is written in the form f of x equals a outside of x minus p times x minus q, where p and q represent the x-intercepts of the related quadratic equation. So the intercept form of the graph, this equation is shown in the graph, and you'll notice that it goes through at x equal to 1, x equal to 1, comma, and we're just going to try and move that, and x equal to 2. This is not a negative, I just messed up when I was drawing it. So you can kind of see x equals 1 and x equals, nope, that was a negative 2. Alright, pause. Apologies for that. X equals 1 and x equals negative 2. And when we put this into our formula, you'll notice that the only thing that changes between our factors and our final solutions is the sign out in front of them. So while this solution is a positive 1, the factor makes it a negative 1. Just something to notice. So then, if I go down here a little bit and it says, what quadratic equation would produce the following roots? Well, I know it's going to be set up as x's, and like I just said, the only difference is the symbol out in front. So instead of this being a negative 3 as a factor, it would be positive 3, and instead of positive, be a negative 5. And then, of course, zero product property gets me this. And then it finally says convert it to standard form, which just means to FOIL it out. So x squared, we have negative 5x plus 3x is going to be negative 2x. And then we've got 5 times 3 is negative 15 equals my 0. That is my final standard form. Alright, I'm going to do the same thing here. I'm going to say x minus 2/3, x plus 2. One way to rewrite this first term so that we don't have to deal with the fraction is to multiply everything inside by the same factor. So I'm going to multiply everything in this one by 3. When I do that, it just makes it look a little bit different, but it doesn't actually change anything. So now I don't have to work with fractions. So then when I FOIL it, I get 3x squared, I get positive 6x, negative 2x, which is going to be positive 4x, negative 4 equals 0, and that is my final factored form. Excuse me. Alright, real world application. I actually really like this word problem. So, a rectangular photograph is 8 centimeters wide and 12 centimeters long. Immediately, I'm just going to draw a picture so that I remember what I'm working with. There we go. The photograph is enlarged by increasing the length and the width by the same amount. Well, how do we say they're increased by the same amount if we don't know what that amount is? Well, we just use a variable. So instead of being 8 over here, it's going to be x plus 8. Excuse me. And then instead of being 12, it's going to be x plus 12 because we're increasing them by the same amount. It says they did this in order to double the area. So we know the area of the first photograph is 8 by 12 equals 96. Well, how do we find dimensions of the new photograph? We have to take the dimensions of x plus 8 to x plus 12, and if we want to double the area equal to 192. They said they wanted this whole thing inside to be 192. Now all I have to do is solve. X squared plus 20x plus 96 equals 192. Get it into the form that allows me to use zero product property. finally get down to my final answers of 4 and negative 24. But now the problem is this isn't my answer. The question asked me what are the dimensions of the new photograph. Well, if I plug in negative 24, I'm going to get negative 18 and negative 12. You can't have negative dimensions, so this answer does not work. I have to use x equals 4 and plug it in to find that my final dimensions are going to be a 12 by 16. So, you have to use a little bit of common sense here right at the end. Make sure you're answering the question it asks, not the question you think it's asking. Alright, if the roots of a quadratic equation are 6 and negative 3, what is the equation for the axis of symmetry? Well, let's think about this. If I graph this on my coordinate plane, the roots are going to be 6 and negative 3. And I know that my axis of symmetry is going to go right down the middle of these. It doesn't matter if my parabola goes up or down. It could go either way. No, my axis of symmetry is going to be right down the middle. Well, what is halfway between negative 3 and 6? Well, the average here would be 9 divided by 2 is going to be 4.5. So I need to go 1, 2, 3, 4.5. So my average, or my line of symmetry, is actually going to be right here. I put it a little far to the right when I was sketching. And I see that's at 1.5, so my equation for the axis of symmetry is going to be x equal to 1.5. And all I had to do was find the halfway point between my first intercept and my second intercept, because I know that that axis has to be right down the middle. Alright, that's all there is to it. Let me know if you have questions.